Hi, I'm Vander Veen. In October, at the Sacramento Clean Tech Showcase, more than 700 attendees got a first-hand look at innovative clean technology from 120 companies. The event, held at Sacramento State University, is part of the Sacramento Area Regional Technology Alliance's Clean Start initiative. The aim of the Clean Start program is to stimulate regional economic development through clean technology startup firms. I spoke with Gary Simon, co-chair of the Clean Start program, as well as two firms offering some cutting-edge clean technology. Here's what they had to say.
And really what clean tech is all about is trying to get to a more sustainable economy, one with a lower carbon footprint. So it's all about switching to renewable energy sources, renewable products, energy efficiency, and that's really what's driving a lot of the companies to form businesses here in the area. Government is a big buyer of products and services, obviously. If one pays attention to buying the greener, cleaner products over the more standard ones, that's what we're trying to show is available. With a lot of the companies that are exhibiting here, people find out that really you're not paying that much more to be clean and green and sustainable. And if you looked at the economics over time, it's actually cheaper to be green and sustainable because of the lower impact on the environment that those products and services provide. But inside our exhibit hall, solar energy companies, fuel cell companies, wind energy companies, energy efficiency companies, all on display here for people to get an idea of what all is possible to be purchased that's green and sustainable. In every community, there are people trying to help. Just as we've discovered 115 companies here within a metropolitan region which is only about 2 million people, there are going to be those opportunities all over. So I think part of it is just understanding what's out there that one could find as an alternative to doing the standard purchasing that a government agency might do right now. Whether it's a fleet, whether it's what's used in the cafeteria for plates, whether it's how you buy electricity and whether you buy from wind and solar selectively, all those are opportunities that a government agency would have to make a difference.
We can design this in many ways. For first responders, we have another box for first responders. It's in a pull case using the same system essentially. What this is metal hydride. So this is your compressed hydrogen here. There's usually 3 in here, but this is compressed hydride. It's delivering hydrogen to the fuel cell. This is the fuel cell here. This is a hybrid system, again, that was requested in this particular unit. So this is the battery, and it works for power surges and saves the fuel by doing power surges. This attaches over here to what we call a squid box. It's just essentially, they wanted separate power supplies for all their medical equipment. This went on board a rescue helicopter.
Oh, okay.
So they wanted medical equipment to be attached all here, and they asked for this particular setup with the DC and the AC up like this. So they took this on. This actually attached to a stretcher. In a military application, they could keep the unit with the patient, with all the other medical equipment, without cables running everywhere. This was one power unit to deliver all their medical power to the patient as they evac them out. This was designed again for them, so this is a 150 watt unit, 150 watt power cell. These deliver 360 to 400 watt hours. So this will run, if you're running at full capacity of 150 watts, this is going to deliver about 8 to 12 hours of power.
So to give you an idea around the technology, we built a photobioreactor. It's a closed loop photobioreactor to capture CO2 from major emitters. Could be a power plant, any manufacturing process, anyone that is in jeopardy with any government legislation for AB 32 or new cap and trade that needs to lower their CO2s. So what we do is we go on site, we capture the CO2, we pump it into our photobioreactor, feed it to the algae. So the algae then takes the CO2 that we pump into it and sunlight, and through simple photosynthesis it grows. Then we take that algae, we create different products from it. We can create biofuels, we can create nutraceutical products, biochemicals, So there's a lot of different types of products that we're looking at creating today. One of the projects we're working on right now, we would actually create compressed natural gas for CNG vehicles.
Okay.
And so from there, we actually take the algae, we put it into an anaerobic digester, and we create methane from there. We create gases from the anaerobic process. We capture our own CO2, so we make it a zero carbon footprint. We bring the methane out to some kind of a compression or filling station, and then what's left over is a char or a material we can use for fertilizer. This is the first round, if you will. It's our first beta. We use smaller piping, a lot different. We built this to try and just start understanding the reaction of the algae with different nutrients. And then we went from this to the larger scale reactor, which is 32 feet tall, 11 feet wide, 25 feet long. We actually have 6 blades that slide into it, and that allows us for a higher density growth.
For GTTV, I am Chad Vander Veen. Thanks for watching.
Let's go in chronological order. Let's say, when did it start?